Okay, this lecture is referring to calculation of center of mass. For this example, suppose we want to formulate it as an optimization problem, and the input data of the problem is as follows. So we want to find out the center of mass of a given set of objects, which their location and their mass are known, and we want to find out what is the x and y coordinates of the center of mass. Okay, so based on the formula, we know that the x of the center of mass is calculated using this formula: xi multiplied by the mass of object I, do the summation over I, divided by summation of all masses. The same formula is for applies for the y coordinate. Okay, so let's have a look at the Python code for this purpose. Okay, so you can see here that at the beginning, as usual, we have to import all the required packages. Here we do need to import pyomo.environment, import everything, import matplotlib.pyplot as plt, import numpy as np, and import random. Okay, we define an abstract model. N is representing the number of objects. I specify the default value equal to 15, but you can easily change that. In order to be able to change that, you can define it as a mutable parameter, and then you have to define the set of objects. If you need the location and also the masses of the objects can be specified as the input parameters. Okay, but you can define them as some random numbers. So you do need to specify them. So x location, y location are the locations of the objects, and the mass is already specifying the mass of each object, and you initialize these parameters using the defined function. So the interval function will give random coordinates to x and y, and also the interval m is giving you some random masses to your objects, but you can also specify them in a file or something like that. And also there are two decision variables, x and y, the center of mass of the overall objects. And since we are trying to find them in a since we already specified the x and y locations between 0 and 1, then the center of mass will be somewhere between 0 and 1. Okay, so I define them as variable, non-negative ones, and I initialized the x and y's using this formula. So initialize some constants. Okay, and then we do need to write down two constraints, one for x, one for y. X is calculated using this formula. It's equal to summation of x location multiplied by their mass, do the summation over all the i's in model I, divided by sum of all masses in the system. The same concept holds for y, and you have to define some constraint for that to be calculated. Then the objective function is the important part here. So actually in this problem we don't have any specific objective function. We just have some constraints that should be satisfied. So you can simply specify x or y as your objective function, and you specify the sense as maximization or minimization. It doesn't matter, because you want to, and there is only one unique solution for that, and there's nothing to be maximized or optimized. Okay, so then you will have to use some solver. So since it's a linear programming, it's better to use glpk as the solver. And then initially I have specified the default value of the objects, the number of objects is 15, but you can definitely change that. You can say it's 5 or 7 or anything else, or you can leave it as it is. it's equal to 15, and then ask Pyomo to solve it for you, and finally you can plot the results. So let's run the code one tab by one tab. Okay, this one is run successfully. How about this one? This is also done, and the final one. So you can see here that there are 5 objects randomly generated here. So you can see them here, and if I change the numbers, let's say it's 6. Okay, so I run this model again, I calculate it. So there are 6 objects here. One of them is very small. So it's here. One of them is here, 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 and here, and here. Okay. So for 6 objects, the location of center of mass is found. You can also print their values. So x of center of mass is found using the formula. So it's here actually. So this is the value of the center of mass. You can also print it if you want, and this is it for this example. Thank you very much.